Today, I'm going to debunk determinism.
Welcome to Missing the Mark, where we look for meaning in strange places. I'm Christopher.
We're going to need a few preliminary notes before we get going. First, a full refutation of determinism that provides all of the necessary background and refutes all possible objections would require a 50-hour-long video. I don't have time to make that, and you almost certainly wouldn't watch it if I did. So, this video is going to give a sketch of how to find out what you need in order to fully understand the subject and come to the conclusion that determinism isn't true. If what you want is an overwhelming argument that will wrestle you to the ground and force you to admit that it's true before it breaks your arm, then this video isn't for you. Second, there are many kinds of determinism, or I should say sources of determinism. Martin Luther came to determinism differently than John Calvin did, and both of them came to determinism differently than some forms of Hinduism do. I'm only going to be addressing the kind of determinism which comes up regularly in my comment section, which, for the sake of brevity, I'm going to call physical determinism. Roughly, this is the idea that our bodies are determined by physics, and so we cannot have free will. If you want a refutation of Lutheran or Calvinistic determinism, I refer you to St. Augustine's letter on grace and free will, written around AD 427. If you want a refutation of Hindu determinism, or some other determinism, you'll need to consult someone who is a scholar of those. And a final note before we get going. The things I'm going to sketch out will require me to also sketch out some background. This means that there will not be a single narrative flow from beginning to end. I'm going to do my best to let you know how the background will relate to where we're going, but to some degree you're just going to have to bear with me because the connections between some things are hard to see until you understand the subject. That said, the basic structure of how I'm going to do this is to start off by outlining the problem, then show why the reasons to believe in physical determinism don't actually lead to that conclusion, then show the reasons to doubt physical determinism, and then I will show the reasons to conclude that physical determinism is not true. And please note, that's not an argument in favor of free will. The point of this video is to debunk determinism. I think that observing ourselves making choices is better proof for free will than we have proof for most things we believe in. France, for example. But in any event, that's outside of the scope of this video. Okay, let's go. The first thing to observe about physical determinism is that we have a conflict between the model and observations. We observe ourselves making choices, but the physical model that determinists use does not allow for this. This is not unique to determinism. Models and observations often conflict. For example, an early model of the moon causing tides predicted 1 tide per day, whereas in many places in the world, there are 2 tides per day. One solution to this discrepancy is to say that the observations are wrong. People miscount the tides or hallucinate a second tide, or whatever you like, but they're wrong. Who are you going to believe, my model or your lying eyes? And that's what physical determinists do. The model says that you can't make choices, so when you perceive yourself making choices, you're hallucinating, or whatever you're doing wrong. But who are you going to believe, the model or your own experience? Obviously, it should be the model. Now, it is not impossible that a person should believe a model over his own experience. People do make mistakes, fail to observe confounding factors, and so forth. It requires some pretty good justification, though, and that we do not have for physical determinism. The most common approach I've seen is to dismiss people's experience of making choices as being mere subjective experience. It should be a tip-off that this doesn't work, that subjective experience is redundant. All experience is subjective. There is no such thing as an objective experience. And here, we get to needing some of that background that I mentioned in the beginning. What I just said will sound weird, or worse, like I'm denying objective truth, which I'm not, if you don't know the history of certain ideas relating to the nature of knowledge. So I'm going to give you a brief history of this, which will make this all make sense. Please bear with me. The original meaning of the word faith is, basically, trust. It is acting according to your knowledge in the absence of direct evidence. To give a concrete example, suppose you have a calculator. You know that calculators are devices which compute arithmetic precisely, and that the calculator you have in your hand was made by people you trust to have made it well, and that machines do not normally vary significantly in their operation, and that this calculator has calculated accurately in the past. So you plug in 1,716,273 divided by 4,917 and get approximately 349.05. You do not know that the calculator is right, but you trust that it is for all of the rational reasons that I mentioned above, plus others that I didn't mention. This is having faith in the calculator. You cannot have apodictic certainty that the answer is correct. Machines can go defective, and human beings can incorporate subtle and malicious behaviors into the machines that they make. But you have good reason to trust it, and so you do. This is rational and good. This is also what Christians meant by faith in God until Martin Luther came along. For various rational reasons, look them up if you're interested, they're not relevant here, Christians held that God creates the world, and that God loves the world, and that God is good, and so they trust him. You can think that they were wrong, but if you think that they were irrational, you're simply uneducated. The problem was that Martin Luther couldn't do that. He was gnawed at by doubt, not in God, but in himself. He was what is technically called scrupulous. That is, he was unable to let go of his sin because of trusting God. He would spend hours in confession and then walk back in 20 minutes later. Modern people who are not trying to be good will not understand this failure mode, but if you've ever tried to be really excellent at something, whether at a skill or just at treating your fellow human beings well, you will recognize this, not as the inevitable result of trying, but as the result of not being able to let go once you've done your best, of not being able to trust. The problem that Martin Luther faced is that you can't get rid of the word faith in Christianity. It's just too central. So he redefined the word to mean not the act of rational trust, but an irrational act of pure will. Thanks for bearing with me so far. We're about halfway there, and when we get there, it will make sense why we had to get there this way. This need to get rid of faith was the desire to have radical certainty, certainty that does not admit of any kind of doubt. The problem is that anything outside of oneself can be doubted. The only things which cannot be doubted are the things that one has made oneself. As an aside, you can see this in people who are manipulative and controlling in relationships. They seek to make the other person prove their love by satisfying demand after demand, effectively trying to turn the other person into an extension of their will. Anyway, the redefining of faith from an act of rational trust to an irrational act of pure will accomplishes the sort of radical certainty that Martin Luther wanted. An irrational act of will is absolutely certain, since it is purely internal, a creation of the one doing the willing. This caused various problems within Christianity, but that's not relevant. What is that the desire for radical certainty became infectious and spread to philosophy. You first see this prominently in Descartes' Discourse on Method, and better developed in Meditations on First Philosophy. These are probably most famous for Descartes' use of the argument cogito ergo sum. I think, therefore I am. It's probably second most famous for his highly questionable proof for the existence of God, But what is rarely appreciated was that Descartes invoked a proof for the existence of God as a lemma, that is a sub-argument, in order to prove the existence of other people and cows and the sun and the earth. You can know with certainty that you exist, cogito ergo sum, but how can you extend that certainty to anything outside yourself? It doesn't matter to the question of physical determinism how Descartes tried to do that. What matters is that he asked the question, and no one, who thought it was a good question, accepted his answer. So philosophy, for the next several hundred years, consisted, in no small part, of trying to give a satisfactory answer to this question. We're almost there. At about the same time that this was happening, the invention of telescopes and microscopes was causing a revolution in human knowledge of the physical world, because we could now see things which were on radically different scales to us. Contrary to some silly fairy tales about science replacing religion, this did not transition people from God did it to cells do it, but just resulted in a change in physical theories as to how nature worked. Mostly, people learned that nature was a lot more complicated. For example, and oversimplifying, wood was no longer thought of as a simple substance, but as a substance built up of many smaller components, cells. The idea that it was a simple substance was an entirely natural idea, just a simpler idea. People, and especially Christians, have generally always believed that nature is natural. What they didn't believe nearly as much, back in the day, was how absurdly complicated nature is. If there's any actual trend of progress in learning about the physical world, it's that it keeps turning out that it is way more complicated than we thought. If there's a lesson in there, it's for the people who think our complete understanding of physics excludes our experience of free will, not for the people who think that our experience of free will shows that nature is more complicated than the determinists think. Be that as it may, this revolution in knowledge was extremely impressive, and the Enlightenment thinkers thought they saw an opportunity for the kind of apodictic certainty that they wanted. So they formulated an idea which was inspired by their understanding of the science that other people were doing, and came up with the idea that certainty can be achieved by sticking to measurable things. It can't. This is a failed project. But we're left with the broken pieces of this idea, and it is these pieces which are used to try to prop up the deterministic model against the experience of free will. We inherit these broken ideas as the distinction between objective fact and subjective experience. Neither can be unambiguously defined because they don't actually work as concepts. An objective fact is supposed to be something that everyone would agree to, but that's not how people work. It is more commonly defined as some quantum, smallest possible unit, of information about the world which is objectively true. But the problem is that you can only get at this information through experience. And as I mentioned before, all experience is subjective. The way you measure the length of something is by comparing it to an object of known length, for example, a tape measure. But the taking of the measurement is done by looking at the two, making sure that they line up. This is done through the experience of sight. And this is not merely a theoretical problem. If you've ever taken a high school physics class with a lab where the groups shared their results, you'll know that different groups can measure the same quantity very differently. I remember, in particular, one lab where our answers for acceleration due to gravity were measured at between about 2 meters per second squared and 7. The correct answer, though in a vacuum, which we didn't have access to, is 9.8 meters per second squared. The fact of the different answers to even very simple problems shows there is not a categorical difference between this kind of fact and other subjective kinds. One approach to trying to deal with this problem is to build machines which eliminate human error. but of course that just introduces machine error. It is normal for a person to weigh a few pounds up or down on different bathroom scales. You can build more precise scales, of course, as well as constantly recalibrate them, but all of this introduces the problem of knowing how well calibrated they are. Basically, it's just kicking the metaphorical can down the philosophical road. And it introduces the further complication of having to know whether the machine actually does what it is supposed to. The latter part isn't so bad on a scale, but there is an awful lot of learning you have to do in order to trust an MRI machine or a scanning electron microscope. You'll notice that most of the skepticism brand disbelievers in God on YouTube will turn apoplectic if you suggest that the philosophical problem of knowledge entails you needing to know how a particular MRI machine works rather than trusting the officials who promise that it does. Apoplectic rage at sacred cows being questioned is one kind of solution to the epistemological problem. It's not a good one. All attempts to privilege certain kinds of experience as being objective, while others are subjective, ultimately fails. I don't expect you to believe me until you spend a few months wrestling with this problem yourself, because this is so heavily embedded in our culture. But if you do, you will find that this is true. And please note that this does not mean that there is no such thing as truth, or that we have no access to truth. There is, and we do. We just can't have radical certainty about it. Once you really wrestle with the issue that there isn't a kind of knowledge available to us with radical certainty that can be preferred to all doubtable knowledge, the attempt to support physical determinism as being based on objectivity, while the experience of free will is subjective experience, falls apart. So we're left with a model which doesn't have room for free will, contradicting our direct observations of reality, and a history of science finding out that the world is more complicated than it thought. You can place your bets as you like on that one, but it gets worse for physical determinism. If you examine what the models are, that is, if you become the kind of science nerd who reads up on science for fun, you'll find that, outside of physics, the scientific models are actually extremely incomplete. This is in no way a knock against science. It's just what reality actually is. The physical world is actually very, very complicated. It's amazing how much scientists have figured out, but it's a tiny drop in the bucket of what there is to figure out. This is especially true in biology. And again, I'm not asking you to take my word for it. Go spend 6 months learning about biology, and you'll start to see how many basic questions have no answers yet. And again, this isn't knocking biology. Biology is awesome. I love it. But it's not a compliment to biology to pretend that it is what it isn't. So it's one thing to say that my highly complete model, which manages to accurately predict everything I've so far tested it against, contradicts your experience. So believe my model instead of your lying eyes. That's a hard sell, but it makes sense why someone might try it. Trust my extremely incomplete model that only predicts the occasional tiny detail, not your experience. Not to be rude, but are you kidding me? Oh, and before anyone objects, well, biology isn't complete yet, but that's not to say that it won't be complete someday, and then free will have nowhere to hide. You can't make claims about the content of models which do not exist. You cannot say what the implications of something you don't know are. Many years ago, there was a hilarious Energizer battery commercial in which a figure in medical garb held up a bottle of some branded over-the-counter medicine and said, "I'm not a real doctor, but if I was, I would recommend these." I don't remember the brand. At that point, the Energizer bunny knocked down the wall and kept going and going and going. But It's a wonderful distillation of the point. Who would listen to a person saying what his recommendation would be if he were a doctor? It might well change by the time he got through medical school and residency. In like manner, it doesn't matter what you think a theory of biology you have never seen would say. No theory up to now has included free will, but if you learn the actual history of science, theories keep getting more complicated, not simpler. Even in physics, atoms were supposed to be the indivisible building blocks of reality. Oops. If you told somebody in the 1600s about radio waves, they'd have thought that you were talking about magic. Oops. If you told somebody in the 1800s about gravity waves or cosmic inflation, they'd have invoked Occam's razor and told you to not multiply entities beyond necessity. Oops. And it gets worse. Because quantum mechanics completely rules out the possibility of proving physical determinism, and strongly suggests that it's not true. Please note, it doesn't rule out proving Lutheran, Calvinistic, Hindu, and so forth determinism, or even just rule them out entirely. They're just, as I mentioned before, out of the scope of this video. Pardon. Ruling out proving it and suggesting it isn't true are two different things, and I will deal with them separately. Quantum mechanics rules out proving determinism because of the Heisenberg uncertainty principle. Using just one instance of it, it is impossible to know both a particle's position and momentum with complete certainty. And the problem for proving physical determinism is that the only way to make the kinds of predictions which, in being verified, might prove it, requires knowing both of those simultaneously. Without that, what you have is a fortune teller who can't foretell the future being used to guarantee that the future is set in stone. By the way, this is not to say that the position and momentum are complete unknowns. They can both be known with some, though not with complete, accuracy. So you can make predictions with error bars, and if the outcome falls within the error bars, you can say, well, technically, that you weren't wrong. So when we put this together, we have very incomplete models, which don't predict much, which at best could make some predictions with error bars that may turn out to not be definitely wrong, against our direct experience. Who are you going to believe, a limited model making vague predictions, or your lying eyes? And, by the way, I didn't even get to the problem of trying to find out the position and momentum of all of the particles within a neuron, in a human brain, without destroying the function of the brain. You can't do that because of the scales involved. We're just too big to non-destructively find positions and momentums, even with moderate accuracy. Of all of the particles in a human neuron inside of a living human brain without injuring the brain. And then we come to how quantum mechanics strongly suggests that determinism isn't true. The quantum phenomena, which have been experimentally verified, are really fascinating, at least to a science nerd like me, but it would make this already long video unwatchably long to go into them. Let me direct you to the double slit experiments, in particular to the single particle at a time variance. We do not, of course, know in a strict sense that the photon goes through both slots. My phrasing is off. We do not, in a strict sense, know that it goes through both slots, interferes with itself, then uses that to pick a place to interact with. But it's kind of fascinating that that's the best explanation that we have, or more technically, that there are no better explanations of the experimental data. It's by no means the only such quantum phenomenon. It's probably just the most accessible. Though also, be sure to look up quantum entangling and quantum tunneling too. They're reasonably accessible. Not quite as, but reasonably. I need to be clear here. I'm not saying that quantum mechanics proves that the world is random. That's not even a definable word in this context, which you will find if you spend a few days trying to really nail it down. I'm also not saying that quantum mechanics shows that the world is composed of will or anything like that. It may possibly suggest it, but it certainly does not prove it. But what it does do is show that the dream of a nice, neat, mechanical world which leaves no room for free will is nothing more than a dream. The world may be some other kind of deterministic, but at its most fundamental level, it's impossible to prove that it's physically deterministic, and when you look at it, it looks very much like it isn't physically deterministic. And here's the thing. You can't build a deterministic system on top of a non-deterministic one. This is just a straight-up insuperable problem. Not that people haven't tried. The usual approach is to say that quantum mechanics holds at the quantum level, but when you have a large number of particles involved, statistics takes over. Sometimes you'll see this described as quantum mechanics not applying in the Newtonian realm. There's a kind of intuitive appeal to this, which is derived from how the world of our experience is reliable. When you pick up a rock, it stays in your hand until you put it down. Whatever is going on at the quantum level, the rock behaves like a rock. So it makes intuitive sense to us that something must turn the bizarre world of quantum phenomena into the familiar world we live in. I think people most often turn to statistics because, in my experience as someone with a master's degree in mathematics, people who don't know graduate level math are very willing to think of statistics as magic. But statistics are not magic. Unfortunately, I can't demystify statistics in a few minutes. I've got a video called The Problem with Probability, which tries in about 20 minutes, but even that is inadequate. There's no substitute I know of for learning the actual mathematics involved, which, to be frank, most people don't have the inclination for, and many people don't even have the ability for. So I'm going to try a shortcut. May or may not work. So if it does, good, and if not, then you have to take the long way. You may have heard of something called chaos theory, and its best known principle, the butterfly effect. Chaos theory is about systems with nonlinear effects, and the butterfly effect is about how a nonlinear system can magnify minute causes into massive effects. The name comes from the example of a butterfly flapping its wings in Chile, causing, some reasonable amount of time later, a tornado in Texas that otherwise would not have happened had it not flapped its wings. A rock is a very homogeneous thing with a structure that gives it very linear effects. Our brains are non-linear systems in which small changes can have huge effects. Just look at the enormous differences in behavior you can see from introducing tiny amounts of psychoactive drugs. I looked it up, and LSD can have significant effects in microgram dosing, that is, millionth of a gram dosing. That is, our brains are precisely the kind of thing which can magnify the tiny, non-deterministic behavior of the quantum world into enormous differences in behavior in the macro world. To put it even more simply, our brain is not a rock. It's not reasonable to expect it to behave like one. That's about all I can say on the simple level. If that doesn't make sense to you, go take a graduate level course in probability in order to demystify statistics and figure out why it's not magic and can't do the work that physical determinists want it to do. And all this, which is a slam dunk on its own as far as debunking physical determinism goes, leaves out the problem of context. I alluded to this before, but to state it plainly, all physical experiments have been carried out in physics labs. Physics labs generally test things in extremely high energy ways. This is because we are so much larger than the things in question that we need to use high energy contexts to get perceptible results. If you throw people against a wall at 40 times the speed of sound, we tend to behave quite a lot like water balloons. It's only when you let us walk around at 1,000th the speed of sound that you really notice the differences between us and water balloons. Further, physics labs are all the same context of being dead matter in a physics lab. There is absolutely no reason to assume that subatomic particles behave the same way in all contexts. For all anyone knows, electrons have twice as many behaviors when they're part of a thinking brain as they do when they're part of a piece of tungsten. Now, for all anyone knows is a very weak argument that it happens, but it is a very strong argument that you can't reason as if you know what's going on. Especially to reason against observed phenomena. As I've mentioned several times, the history of science is largely the history of finding out that the world is a lot more complex than anyone thought. So, when we put it all together, the case for physical determinism is: my very incomplete model, which doesn't actually suggest physical determinism, and which couldn't prove physical determinism even if it were complete and did suggest physical determinism, doesn't include free will. So your frequent and direct observations of free will must be a mistake. Okay. Look, I'm not by disposition very sympathetic to determinism, but I get that you want the world to be simple and clean and easy to understand. But it isn't. It's messy and complex, and we can't fit it inside our heads. So be a determinist if you want to. But if you're going to, please pick a better determinism than physical determinism. And until next time, may you hit everything you aim at. If you like this video, then clicking the like button, according to YouTube, will make them more likely to recommend it to others. If you know anyone who might get something out of this video, then it would be kind to share it with them, or just share it on social media in general. And if you'd like to see future videos of mine, you can subscribe. And if you're not in the habit of checking your subscriptions page regularly, then I suggest clicking the notification bell and setting that to always, because otherwise subscribing to a channel basically just sort of like gives YouTube a hint that maybe it should consider recommending these videos to you, possibly at some point, if they think so. It's a funny world we live in. God bless.